Hey y'all. So we've already learned about matter, and in today's video, we're going to learn about the periodic table. The periodic table is a tool that we're going to use throughout the year and has been used by scientists and chemists to place different elements based off of their properties. So let's take a look briefly at how the periodic table came to be and how we're going to utilize it this year in class. So let's start by talking about how the periodic table had its origins. Now, elements and matter have been discussed for thousands of years, but it really wasn't until the 1800s when Dmitri Mendeleev really started to identify different properties of elements and place them on this rudimentary table based off of their molar masses, which is how much each atom weighed, and based off of their chemical reactivities. So this is Mendeleev's original periodic table. Now, in his infinite wisdom, he actually left gaps on the periodic table where he believed other elements should have been, but might not have been discovered yet. And so over the years, scientists have found those elements, filled in those gaps, and now we have a very much more complete periodic table that you can see here. Mendeleev's table, again, like I said, he grouped them based off of how much each atom weighed, and he ranked them in increasing weight. So the lighter elements were up the top and on the left, and the heavier elements were on the bottom and on the right. Also, he grouped them based off of how they reacted. So elements that shared properties were grouped together vertically. All of those same principles are going to apply in our current periodic table. Starting with a grouping that is as broad as one can get, we're going to look at metals versus nonmetals. Now, metals on the periodic table are going to exist mostly to the left and lower on the periodic table, whereas nonmetals are going to exist, generally speaking, on the top and right sides of the periodic table. So if we can look at the color coding here, we can see that there's two major groupings, metals and nonmetals. However, there is a group known as metalloids, or a classification known as metalloids. And those are interesting because they share some of the properties of metals and some of the properties of nonmetals. Now, the periodic table that you're going to be using this year won't have any color coding. So you're going to have to be familiar with the things in our periodic table that are metals and the thing in our periodic table that are nonmetals. Normally, we're not going to be dealing with too many metalloids in AP Chemistry this year, but it is really important to know that they do exist and that they share the properties of metals and nonmetals, and they're somewhere in between those two. So now that we've talked about the two major classifications, metals and nonmetals, let's get a little more specific. When I said that Mendeleev grouped the periodic table that he created based off of chemical reactivity and properties of the elements, we're going to continue to discuss those as groups. So vertical columns on the periodic table are known as groups, and in some cases known as families. These are all going to be groups of elements that share very similar reactivity properties. We're going to talk a little bit more about why they share reactivity properties a little bit later in this conversation, in this unit. But in the end, you do need to understand that if two elements are on the same group or in the same column on the periodic table, they share a lot of chemical properties as each other. In addition to vertical groups, which have chemical similarities, there are also horizontal periods on the periodic table, which are going to provide the ability to repeat those vertical groups while still increasing in mass. Now, later in this unit, we're going to talk about why elements are going to be in the same period, and it really has to do with where their electrons exist. But that's something for a later video that we're going to discuss. Just understand right now that vertical is a group, horizontal is a period. So oftentimes when we call a group a family, it's because it has a name. So the names that you need to be familiar with this year are the alkali metals, that's going to be in the first group or the first column. The alkaline earth metals, those are the ones in the second column or the second group. The halogens, which are in the seventh group, and the noble gases, which are in the eighth group. The oxygen group is sometimes known as the chalcogens, but you don't really need to know that this year, but you might see that word thrown around from time to time as well. Now that we've had a chance to look at how different groups are created on the periodic table, let's just take a second to think about this in a practice problem. So here I've given you two pairs of elements, and I want you to tell me, based off of what you know, which ones share the most similar chemical properties. The first pair is sodium and magnesium, and the second pair is sodium and potassium. So which of these two pairs would share the most similar chemical properties? Well, it's going to be the sodium and potassium. And the reason is because, as we have said, they are in the same group, the same column. So now that we've talked in broad strokes about what the periodic table looks like, let's get into the box itself and start identifying some of those numbers and symbols that we can see inside of the actual periodic table and that we're going to be utilizing this year in many of our calculations and conversations. One thing to be aware of is in AP Chemistry, you are not going to be given any of the elements' names. You will only see the symbols. And as a result, you're going to have to be familiar with exactly what the names of these elements are. Now, most of the ones that we're going to be concerned of, you're going to use from time and time again. So you're not going to have to memorize this. It's just going to come from utilization more than anything else. The first thing you're going to see on the periodic table is the element's symbol. This is a 1 or 2 letter abbreviation and does not always match the English first 2 letters or the first letter. And the reason for that is because of the fact that many of these come from a Latin origin. For instance, lead is PB, that's plumbum, all right? And tin is SN, that's stannous. Again, these are going to be ones that you're going to be more familiar with as you go, but it's just to be aware of that some of these do match. For instance, we have potassium, right, which is K, but then we have hydrogen, which is H. Okay, so we can see that different elements have different symbols, and you're going to get familiar with these as we go through the year. But just so you're aware why some of them, the first letter or first 2 letters that we see, the symbol doesn't match the English spelling. So here we have the hydrogen atom as we would see it on the periodic table. The elemental symbol for hydrogen is H. And there are several numbers that we can see now. Let's get into what those numbers represent. The number at the top is 1. Now, this is a whole number, and you're going to see on the periodic table, there's always going to be a whole number that is at the top, and that whole number at the top is going to represent the atomic number. The atomic number of an element is how many protons that element has in the nucleus. The number of protons is specific and unique to each element. So if you change the number of protons, you're simply changing the element's identity itself. So 1 proton in the nucleus is always a hydrogen atom. The second number, which is often not a whole number and often has decimal places after it, is the atomic mass or atomic weight. We are going to measure this in 2 units. One is going to be AMU, which is atomic mass units. And secondly, in molar mass, which is grams per mole. Now we're going to get into what that unit means later on in this unit, but just so you are clear, when we look at the number in the periodic table that is decimal form there, in this case 1.0079, that number represents the atomic mass of a hydrogen atom. And specifically, the reason it's a decimal is because it's the average atomic mass of all hydrogen atoms. When we get to a couple of videos further in, you're going to see that not every atom of every element has the exact same mass. Let's do a quick practice problem to show what we just talked about. Now, here we have an element, and I'm going to give you the name of this one. This one's carbon. So what I want you to do is I want you to tell me 1, 2, and 3, what does each represent? So take a second, look at each, and label 1, 2, and 3 with exactly what they represent. So number 1 represents the atomic number, which, remember, is the number of protons in the nucleus of a carbon atom. So each carbon atom has 6 protons in it. The element's symbol, or atomic symbol, is C. That's our capital C, and that represents a carbon atom. And then below that is the atomic mass, or atomic weight, and that represents the average mass of carbon atoms that exist. So let's look at this next one. How much does the average atom of sodium weigh? Did you say it weighs 22.990 grams per mole or 22.990 AMU, atomic mass units? If you did, that's right. Remember, that decimal at the bottom, which isn't always a decimal, sometimes there are whole numbers down there, but normally because different atoms of each element may weigh something different, that is a decimal number, decimal value. So this sodium atom, on average, would weigh 22.990 grams per mole, or AMU. So that wraps up today's video. Let's do a quick recap. Today we talked about the origin story of the periodic table. But remember, in AP Chemistry, I'm not going to be worried so much about the history or the people. However, it is just good to know, but I'm not going to test you on that kind of thing. What I do need you to understand are the basics of why the periodic table is organized the way it is. Vertical groups, remember, are organized based off of chemical reactivity. So if two elements share a group, that means they react in a very similar way, chemically speaking. Secondarily, periods, horizontal groups, are arranged based off of increasing mass. So as the elements get heavier and heavier, they're going to go from the left to the right on the periodic table. And then as you go vertically up top to bottom, you're also getting heavier as you go down the periodic table. When Mendeleev first discovered this periodic table, he left gaps. We've now pretty much filled in all of those gaps, and at this point, we're just expanding the periodic table to the furthest reaches that we can. So as we get further and further down that periodic table, we're starting to create those later and later elements. But understand that when we use the periodic table, most of what we're going to be using are those elements that are going to be higher up on the periodic table, and that's just because those are the ones that are going to be more common in existence. The other thing to remember about the periodic table is that we're going to be utilizing it to gain information about each element. This video was written, directed, and produced by Lucas Pinto. I hope you enjoyed it, and I'll see you in the next one.